Welcome to the second lesson on Surds. Hopefully you have watched the first lesson from a couple days ago and practiced some of the questions that I left for you to follow up on, which hopefully would have helped you with these questions on the starter here. We'll start by going through these. And if we start with the top left, you've been asked to simplify. So if you recall, one of the exam tips I gave you was to always write out your square numbers when simplifying surds, because it's very, very useful, because the exam skill that I gave you was to simplify a surd, so root 48, we're going to split it into two blank surds. Recalling that one of these surds needs to be a square number, and preferably the biggest square number you can find. So if we're looking at 48, we need to think which one of these square numbers go into 48, preferably the biggest one. The biggest one would be 16. So we could say 16, and if you recall, law 1 states that we can times these two surds together to make this surd. So what do we times 16 by to get 48? The answer to that is 3. Why is this useful? Well, 16 is a square number, and if you square root a square number, you're going to get a positive integer, so the square root of 16 is 4. So the answer to this is 4 root 3. Alternatively, if you didn't spot, I know it needs to be broken down into two blank surds. I know that 4 goes into 48. How many times does 4 go into 48? 12. I know that the square root of 4 is 2, so I've got 2 root 12. If you go down this route, you always have to ask yourself, is this surd as simple as I can get it? Can it go any further? Can I break this into two surds where one is a square number? Well, the answer to that is yes. So it requires a little bit more work than this one. If you find the biggest number that goes in, that is square, you get the answer straight away. Here, as you can see, this answer is not the same as this answer. So we're going to need to work on this one a little bit more. So we can say that this is 2 times 2 blank surds, because I realised that 12 has a factor of 4, which is square. So I could say 4 times by 3 makes 12. And we know that root 4 is 2 times by root 3. If I tidy this up, 2 times 2 is 4 times by the root 3. So that would be 4 root 3. So as you can see, we get the same answer, whichever method you went. However, it is very advantageous to use the biggest square number you can find, because as you can see, that was done in one step. This required 2 steps. Moving over to the expand and simplify question. We looked at these last lesson. This relies heavily on 2 things. One, knowing positive and negative multipliers. So when you multiply a positive and a negative number, you get a negative. And secondly, how to actually expand out a bracket, along with the surds rules that we learned. So the 3 laws. We'll start by using the FOIL method. So 2 times 3 is 6. 2 times, remember, that isn't root 5, it's minus root 5. Technically, we would say this is minus 1 root 5, so 2 times minus 1 root 5 would be minus 2 root 5. Now we're going to go, root 5 times 3 would be plus 3 root 5. And then root 5 times minus root 5. This requires 2 things. First of all, positive times a negative is a negative, a mixture makes a minus. And secondly, root 5 times root 5. The law here that we need to know is the same surd times together cancels the square root. And we looked at why that happens last lesson. So root 5 times root 5, following this law, which was law 3, would state that we would just be left with 5. We can now tidy this up. We can say that, what have we got? We've got 2 whole numbers that can be simplified. and 2 surds that can be simplified. And we sort of touched on last lesson, you can only put surds together if they are of the same surd. So we can see here these are both root 5s. You can think of this as minus 2x plus 3x. What would you do there? You just do 3x, take away 2x, or minus 2 plus 3, same thing. You treat the surds exactly the same. So we'd end up here with 6 minus 5 is 1. And then minus 2 root 5 plus 3 root 5 would be plus root 5. Or you could say 1 root 5. Exactly the same. Similarly, x is 1x. We just don't normally write 1x, we just write x. Same here with surds. You wouldn't really write 1 root 5, you'd just write root 5. Okay, moving on to the bottom left. Very similar to the last question. You should realise squared means that I need to write this bracket out twice because I need to times this by itself. And we're going to use the same method, root 3 times root 3. So there's a lot more laws that we need to implement here. Root 3 times root 3, well, it's the same surd times together, so the surd cancels, so 3. 3 times 2 root 2, that is going to be 2 root 6, because recall that root A times root B, so 2 different surds times together, can be written inside 1 surd times together. Essentially the opposite of what we did here. So root 2 times root 3 is root 6, and then you've got the 2 as well. Moving across, 2 root 2 times by root 3 would be plus 2 root 6 again. And then finally, we've got 2 root 2 times 2 root 2. So 2 times 2 is 4. And then root 2 times root 2, recalling again, the same surd times together, gives me just what is inside the surd cancels, the square root cancels. We're going to end up with times by 2 because the square root's gone. Now we've got some tidying up to do. Well, these surds can go together because, as discussed a second ago, they are the same surd, they're a root 6, and then we've got some whole numbers that we can put together. This bit here we need to just times and work out what it is, but what do we get? We've got 3 plus 4 times 2. 4 times 2 is 8, so 3 add 8 is 11, plus 2 root 6 plus 2 root 6 is 4 root 6. If you did this and wrote it the other way, like that, same answer, they're both correct. Okay, so it doesn't matter which way you have your answer written, it would be the same answer. Okay, moving over to this. This is just recalling how to factorize. So remember, this is a quadratic. Okay, so the first thing you should spot is this is a quadratic. When you are asked to factorize a quadratic, you must put it into 2 brackets. And what we need is 2 numbers that multiply together to make minus 24 and add together to make minus 2. So we need 2 numbers that times together to make minus 24 and add together to make minus 2. So the way I lay this out is I write minus 24 there and I think about what are my factors of minus 24. Well, first of all, minus. How do you make a minus? By timesing 2 numbers. You need a mixture. You need 1 positive and 1 negative. So we could have, and then you just need to know your factors of 24. We could have minus 4 and 6. Or we could have the opposite to that, because minus 4 times 6 is minus 24. We could have 4 and minus 6. Both of those, if you times them together, will give you minus 24. Which one of these adds to make minus 2? Well, minus 4 add 6 is plus 2, but 4 take away 6 is minus 2. So we're looking at this one here. So to factorize this bracket, we should know that that is x plus a 4, which I found here, and that is an x minus a 6. Now, we can use the FOIL method, and if you expand this out and simplify, you would get this. Okay, so hopefully you had a go at some of those. You definitely would have had to have used all of the laws that we learnt last lesson for the surds, and this is something that we are going to expand on now. So if we move across to the first part of this lesson, adding surds. I should have really wrote adding and subtracting, so you might just want to add that note in because it's exactly the same. Similar to fractions, if you have a rule for adding fractions, it's the same rule for subtracting, the same with surds. The first note that I would like you to add is that, and I've said it before, in the last lesson I said it a minute ago, you can only add or subtract surds that are the same. Okay, if they're not the same, you need to either make them the same, and if you can't make them the same by simplifying, you just cannot add them. Okay, and we'll look at some examples of that now. So you can only add or subtract surds that are the same. So if they aren't the same, you try and simplify to make them the same, or you cannot do it. So if we look at this worked example on the left, it's asking us to do 2 root 5 plus 5 root 5. Well, first question, are the surds the same? They're both root 5, so that's good. We can add them. And it's just like adding, if that was 2x plus 5x, you would get 7x. Exactly the same principle. 2 root 5 plus 5 root 5 would be 7 root 5. So a lot of students get confused with the rule that states root a times root a is a. They get confused with that rule there when adding, and they see two surds the same and think that this cancels, that the square root disappears. It doesn't. Those rules are separate. When the surd cancels is when we are strictly timesing. When we're adding, you treat them like you would add x's or y's of the same term. Moving on to the next one. It's asking me to add 2 root 20 plus 5 root 5. Well, given the statement I made a second ago, and hopefully the one that you wrote down, they are not the same surd. One is root 20 and one is root 5. So I can't add those together. Yeah, a common mistake would be, oh, that's 7 root 25, because they add the 2 and the 5, and they add the 20 and the 5. That's wrong. Yeah, you cannot do that. Cannot happen. So we can try and manipulate the root 20 to see if we can get it down to root 5 to make them the same. So let's think about simplifying surds. How do we simplify a surd? Exam skill. We're going to break it into 2 surds. And remember, one of them has to be a square number. So what square number do we know that goes into 20? Hopefully you're thinking to yourself, 4. 4 is a square number and it goes into 20. Root, what do you times 4 by to get 20? 5. And then we've got the plus 5 root 5. So we cannot simplify root 5 because it is prime and no square numbers go into it. So that is as simple as it will go. And as you can see, hopefully you've spotted there, oh, root 5. Looks like we're on track. Let's tidy up this bit here, given what we learnt last lesson. What is root 4? We know plus 5 root 5. Well, what does that give us? 2 times 2 is 4. So we've got 4 root 5 plus 5 root 5. Yeah. So this 4 has come from this, being times together. Now we can add them. They're the same. Happy days. We can add them together. My final answer will be 4 root 5 add 5 root 5 is 9 root 5. Okay, so the answer to that is 9 root 5. Sorry for cramming it in there. Right, moving on to the next one. Can we add these together? No, we can't. We cannot add these together because this is root 20 and this is root 10. So what we need to do is see if we can break these surds down to be the same. So we'll start with this one. 2 times, remember, 2 blank surds, because we're simplifying it. 1 needs to be a square number. What square number do we know that goes into the 24? And the more you do surds, the more they just use the same numbers in exam questions. So if you expose yourself to a lot of surd questions by doing what I've put in these worksheets, doing the extension questions, you'll start to realise they only use the same numbers over and over again. So you get very used to knowing what square numbers go into them. It's 4 and 5. And we can tidy that up because that is 2 times 2, because the square root of 4 is 2, times root 5, which is going to give us 4 root 5. Okay? So we need to look now, can we simplify root 10? Does any square numbers we know go into root 10? We've got 5, well, no square numbers. If you think about your square numbers, you've got 4, and 3 times 3 is 9, and then there's no point doing any more because it's bigger than that. So what we can see here is, simplifying this surd down to root 5 does not make these the same. Okay, so we cannot actually add these together because they don't go to be the same. This is as simple as it will go. So I'd like you to have a go at those 2 there. So hopefully you can see the first one you can do very, very quickly. They're the same surd. That would be 2 plus 5 is 7 root 6. Okay, and then focusing on the next one. Root 6 cannot be simplified anymore, but we definitely could look at, can we simplify root 54? So we're going to break it down. We've got 2 times root times another root, because we need 2 times together with a square number, which is going to be, if you think about your square numbers, what goes into 54, 9 and 6. Okay. Well, that's handy because the square root of 9 is 3, so we've got 2 times 3 times root 6. Okay. Which will give you 6 root 6. So what we end up with here is 6 root 6 plus the 5 root 6, which will give us 11 root 6. And that would be your final bit for that. Okay. And the last one, very, very similar story to the other one. If you break root 20 down, you're not going to get the same surd, so you're not going to be able to add them together. Alright, you could try, but that will give you root 4, root 5, and you're not going to be able to add them together. Alright? So, same with subtracting. We haven't got any subtracting examples here, but it's exactly the same process. See if you can simplify the surd down to become the same surd to be able to add them together. If you can't, you just can't. Okay. So moving on to what is starting to be considered the harder part of surds. So we're just going to have an introduction today about rationalizing the denominator. Then we're going to move on in Surds 3. We'll be looking at the really difficult questions where you're asked to do every single thing that we've learned about Surds in the most complicated way possible for GCSE. So rationalizing the denominator sounds really difficult, but let's just explore what it actually means, because it's quite straightforward. First of all, we're just going to recall something that we spoke about last lesson, which a surd is an irrational number. So if we've got this root 3 here, that is an irrational number, and it's a decimal number that goes on forever. Most square roots are irrational, apart from what we've looked at, square numbers, special relationship. When you square root a square number, you get a whole number. Whereas most other surds are irrational, which essentially just means root 3 long decimal that doesn't recur. It doesn't recur and goes on forever. Right? So if we look at this case study here, and this is all about what rationalizing the denominator means. Okay. If we have 5 over root 3, I should say. The reason that this is a problem that we want to sort in maths is because if we just discuss that root 3 is a decimal, we really don't want to be dividing by an irrational number. We don't want to be dividing by a long decimal. Okay? So the goal of rationalizing the denominator, the whole point behind it is we want to get rid of the surd on the bottom of the fraction, on the, if we were going to use technical language, on the denominator. Okay? We want to get rid of the surd that is on the denominator, the bottom of the fraction. So how do we do that? Well, it's going to require you to have definitely some surds understanding, but also some fraction understanding as well. My goal, as just discussed, is to get rid of this surd that is on the bottom of this fraction. Well, if you think about surds, we know a law that allows us to get rid of the surd. So hopefully you might be thinking, I know that. I know that root A times by root A is A. 2 surds times together equals the same surd. Okay? Which means that's very useful, because if I want to get rid of this surd, I can use this law. So remember, this was law 3. That now brings you into a little bit of fraction knowledge. I want to times, using this law, this root 3 by itself. So I want to times it by root 3. Okay? Because I know if I times this together, root 3, and again, you have to know when you times fractions, you just times across the denominators and across the numerators. I know that I can do root 3 times root 3, which will give me 3, because it's going to get rid of the surd. However, there's one extra step that you need to make sure you follow. If you do something to the bottom of a fraction, you must do the same to the top, and vice versa. You should know that. When you make a common denominator, whatever you did to get the common denominator, you've got to do the same to the numerator. We have to make sure that we also times the top by root 3. And if you think carefully about what we're actually doing, what is root 3 divided by root 3? Just 1, a whole. Yeah? How many root 3s go into root 3? 1. So essentially all we're doing is timesing this whole thing by 1. But we're using some Surds laws to manipulate it. So you see what you've got on the bottom. I need to get rid of root 3. You've got to times the bottom by root 3 because that would eliminate it. But fraction laws tells us to make sure we're doing everything correctly, we have to do the same to the top. So once you're clear on that, it's nice and easy. You just have to multiply across. We're going to do 5 times root 3 and then 3 times root 3. So 5 times root 3, we can know that we can just write it as 5 root 3 over root 3 times root 3 gives me 3. And that is that question complete. So we've just taken a surd that was at the bottom of a fraction. We wanted to rationalize it, which means we'd never want to have a surd on the bottom, so we need to get rid of it. We use law 3 to do it, and we've just ended up with another looking surd where it's now on the top, not on the bottom, which is what we want. The goal to this entire question was just to get rid of this root 3 that was on the denominator of the fraction. And you do that by manipulating and timesing by the same surd using law 3. So quite a lot to comprehend, but quite straightforward. And when we start to look at some examples now, you'll realise, oh yeah, that's quite simple. Okay, so if you swipe across or get the next sheet of paper out, we want to rationalise this surd. The first thing you should spot, and you should always be thinking when doing surds, I don't really ever want a surd on the bottom of a fraction. So I want to get rid of it. So I want to rationalise it. How do I rationalise it? I'm going to times it by the same surd on the bottom. Yeah, because I know that root 11 times root 11 is just 11, yeah? And that's achieved my goal. However, fractions rules state if I times the bottom by root 11, I have to times the top by root 11 to make sure I'm not actually changing the answer, the question itself. So, I make sure I times the top by the same, then it's just basic fraction rules. We're going to times across, you get 3 root 11 over 11. And that's that one done. Obviously, you're never going to get something as quite straightforward as that. They're always going to make it a little bit more challenging by bringing in some of the other surd aspects that we've learned so far. So if we look at example 3, this is more in line with what you might see in a question paper. So again, what's my goal here? I do not like the fact that there's a surd on the denominator, so I'm going to try and get rid of it. We know that to get rid of a surd, you can times it by the same surd. Given if you're unsure about why that is, look at Surds 1 lesson, and I actually explain in detail why it disappears. But I need to get rid of this root 3. So how am I going to do that? Well, I know if I times root 3 by root 3, the square root's going to cancel. It's going to be gone. But I must make sure I times the top by root 3 as well. Now, where this question gets a little bit more interesting is on example 2, there was just one thing that I was timesing by the surd. Here, there are 2 things. Now, it's crucial. It's very, very, very important that you put a bracket around that because there is more than one term. So we need to multiply root 3 by this and root 3 by this. Okay, it's like expanding a bracket because there's more than one thing. So if I do that, we'll start with the bottom because we know that root 3 times by root 3 is just 3, which is good. That's the goal, right? If I times the top, we're going to do root 3 times by 13. Well, that just simply gives me 13 root 3. Okay. Now we're going to do root 3 times, remember, it's not 9 root 3, it's minus 9 root 3. So that's a positive and a negative, so I know I'm going to have a negative. And we're going to do 9 root 3 times root 3. Well, what do we know? We know that root 3 times root 3 is simply 3. So what do we actually have? We've got 9 times 3, because the surd cancels due to the fact we've times it by the same surd. Therefore, we can tidy up the top now. What have we got? We've got 13 root 3 minus 9 times 3, which is 27. So we've got 13 root 3 minus 27 over 3. That is an acceptable answer, because the whole goal to this question was to get rid of this root 3 on the bottom of the fraction. We've done it, yeah? We've moved it up to the top and changed that around a little bit, but the whole goal has been achieved. Key thing to take into consideration here, I had to put brackets because I'm timesing by more than one thing. And you do the same to the bottom as you do to the top. Okay. There's an alternative form that you could write that in. You might spot here, 3 actually does go into 27. So you could split that and just have 13 root 3 over 3, and then minus what is 27 divided by 3, that would be minus 9. So those two answers are the same. It's just I've split them into 2 fractions and realised that that does actually go into 27. However, I'm quite lazy. This is a lot easier just to leave your answer like this. But if they ever ask you to have it in a certain form, just be aware that you can split this and this into 2 separate terms. Okay, moving on to example 4. Example 4, again, it's up in the amount of surds things that you have to do in one question. Initially, you should spot it's asking me to square. So we should probably deal with this first bit before we start trying to get rid of the root 5. So if we do that, let's just first of all write out what does that mean when I square it. It means 2 root 3 minus root 2 times. So the first thing that we should probably do is expand out these double brackets before we start to rationalize the denominator. So if we do that again, we'll use the FOIL method. We'll do 2 root 3 times 2 root 3. Again, this refers back to what we learned last lesson. We can do the 2 times the 2 and then the root 3 times the root 3. What do we know? And you have to be really careful when laying this out and doing this. We know that 2 times 2 is 4. And then root 3 times root 3 gives me 3 because the surd cancels. So that's 4 times 3. So that's that first bit done. Now we're going to do 2 root 3 times minus 2. Remember, this is minus 2, not just 2. So what does that mean? That means we've got a minus and a plus, so I know it's going to be a minus. And then we've got 2 root 3 times root 2. Well, we can use law 1 that says root 2 times root 3 is root 6. So that is essentially minus 2 root 6. Moving on, we're going to do, again, it's not just root 2, it's minus root 2, minus 1 root 2, times by 2 root 3. So that's, again, a mixture. It's going to be a minus. And we've got a minus and a minus, as I know it's going to be a plus. Okay, so we've got a plus. And we've got root 2 times root 2. Well, we know, we've been doing a lot of this. We know root 2 times root 2 is 2. Okay. All over, still root 5. So before we do anything now, we should definitely focus on the top and see if we can tidy it up, because it's a bit of a mess right now. Things that go together. We've got a whole number here, once we times it, and a whole number here. Then we've got 2 surds that are the same. And we just looked at, can we add or subtract surds when they are the same? Yes, we can. So what we've got here is 12 plus 2, because 4 times 3 is 12, so that's 12 plus 2 is 14. Then we've got minus 2 root 6, take away another 2 root 6. So if I'm at minus 2 and I take away another 2, gets me to minus 4. So that is minus 4 root 6 all over root 5. So this question, as you can see, they become quite involved. I haven't even started to do what I need to do yet, which is rationalize the denominator, aka get rid of the surd that is on the bottom, which I can do now. Now that I've made the top something a lot more manageable, we can now go ahead and do what the question actually wants us to do, which is rationalize the denominator. I need to get rid of root 5. I can times it by root 5, remember? Which means I have to, fraction rules, I have to do it to the top as well. So let's deal with the bottom first. Root 5 times root 5, 5. So we've just achieved the goal of this question, which is to get rid of the surd on the bottom. And then we're going to times the top. So we've got root 5 times 14, which is simply 14 root 5. Then we've got root 5 times minus 4 root 6, which is going to be minus 4 root 30, because I can simply put those together. Can we simplify root 30? We should ask ourselves, does any square number, and again, a good exam tip would be to write square numbers out: 4, 9, 16, 25, 36. We don't need to go any more because we're only looking at 30. Well, do any of those square numbers go into 30? 4 does. So we could leave our answer like this, or we could get it down even more if we wanted to. So if we just looked at what the steps involved to simplify it again would be, we could say that we've got 14 root 5 minus 4 times by 2 blank surds, where one is 4 and the other is 15, because 4 times 15, 2. No. 4 does not go, what am I talking about? 4 does not go into 30. Christ, lost my head. We cannot, it doesn't. No square numbers go into 30. Don't know what I'm on about. So that is our final answer. Okay? Our final answer is 14 root 5 minus 4 root 30 over 5. So quite an involved question. We're asked to expand a double bracket, simplify it using all of the things that we know, then rationalize the denominator. Okay? So what I've got for you is just a couple questions before we move on to the even harder stuff. I just want to start by looking at this first one with you, because this touches on what I did at the end of the last Surds lesson. Most students will go wrong on these questions due to this bit here, this minus. So I'm going to do it quietly, without talking, and I'll just come in at the end where students make mistakes. So if you can also just start to answer this question, I want you to expand this one out, expand this one out, and then I'm going to come in when I've got to that point and I'm going to talk about how you don't make a mistake at the bottom part of the question. Just be careful when you're expanding out this second bracket. Root 3 times root 3 is 3. But you've got a minus and a minus, which makes a plus, so just be very careful with your signs. Okay, so hopefully maybe you paused it or you sort of was in time with me. Hopefully you expanded both brackets and you got 7 plus 4 root 3, and then for the other one you got 7 minus 4 root 3. Now I talked about this last lesson. Most students here, they see the minus sign in between and they think to themselves, right, 7 take away 7 is 0, and then 4 root 3 take away 4 root 3 is also 0. So they'll get 0 for their answer. They always get 0. However, we need to be so careful. What is this telling us? It's telling us, to finish this answer off, we've got the first bracket, which we said was 7 plus 4 root 3, minus the second bracket. So minus, and again, if you're minusing more than one thing, put it in a bracket. We're minusing this, which has more than one term. So I'm going to put it in a bracket. So it's minus 7 minus 4 root 3. Now, if we look at this question now, we're not going to get 0. Because 7 minus 7 is 0, so that's gone. 4 root 3 minus 4 root 3. Well, we know, don't we, that a minus and a minus is a plus. Okay, a minus and a minus makes a positive. So that is actually saying to us 4 root 3 add 4 root 3, which is 8 root 3. Okay, so hopefully you managed to expand the brackets fine. It's just that last bit, they always put it in questions with a minus. Students always get 0 because they see you've got the same thing and you're taking it away. But a double negative stops it from being 0. Okay, so hopefully you can rationalize those denominators. And these first couple, very quick. Just using that rule that we spoke about. So if you times the top and bottom by root 3 to eliminate the surd on the bottom, you would get 6 root 3 over 3. Now we can simplify this, because if you can see 6 and 3, 6 can be divided by 3. How many 3s go into 6? 2. The answer to that, as simple as it will go, is 2 root 3. Same story on the bottom. Times top and bottom by root x to eliminate that surd. We're going to get x over root x divided by root x times x is x. Now very, very similar here. We can cancel, and again this is just some basic fraction understanding. Those x's will cancel to just give me my answer as root x. You put brackets when you, hopefully you realise I need to times top and bottom by root 2. There's more than one thing on the top of my, more than one term I should say, on top of my original fraction, so it needs to go in a bracket, and I need to expand the bracket. So I'm going to get 1 times root 2 is root 2. Remember, root 5 times root 2 is root 10 over 2. Can we break root 10 down? No, no square number goes into root 10. So we cannot add these surds together, they have to stay independent. Okay, so the key is you need to times by the same surd on the bottom and top to get rid of the surd on the bottom. And just be careful with all the other rules that we know. If you know the rules, it's all pretty much the same. This grade 7, so we're going to times top and bottom by root 3. They've already put it in a bracket for us, which is nice. So we can times it. The bottom is the easiest thing to do. Remember, root 3 times root 3 cancels the surd. And on top, we've got root 3 times 3, which is simply 3 root 3. And then root for this. Can't simplify 3 root 3. But I can simplify root 18. What square number do we know that goes into 18? 9. 9 goes into 18. So I've got 3 root 3 plus 2 blank surds all over 3. We can break 18 into 9 and 2. So that gives me 3 root 3 plus the square root of 9, we know, remember, is 3 root 2 all over 3. Root 3 and root 2 cannot be put together because they are different surds. And then finally, very, very similar to the example that we saw in my example, number 4, I believe. We've got to do a double bracket expansion, tidy it up, and then rationalize. So we can start by expanding the top and just being really careful. I can see here we've got a positive and a negative, so it's about remembering those rules. Mixture makes a minus, same as a plus. So we're going to do 4 times 4, 16. I'm going to do 4 times, careful, minus 2 root 3 would be minus 8 root 3. Then 2 times 4 is plus 8 root 3. And then finally, be really careful on this last one, you've got a few things to worry about. We've got a minus and a plus, that's a minus. We've got a 2 times a 2 is a 4. And then we've got a root 3 times a root 3. Well, we know the whole part of this lesson was about the same surd times together will give me just 3. All over root 11 still. Let's sort the top out. What like terms have I got? I've got these whole integers, these whole numbers. They can go together. And they are the same surd of a root 3, which means they can go together. And what you can spot here is we have 16 take away 4 times 3 is 12. 16 take away 12 is 4. Minus 8 root 3 plus 8 root 3. That in fact goes to 0. That cancels each other. So that's 0. So that's gone. So we're left with simply 4 over root 11. Which is nice. It's nice to see all of that horrible looking numerator simplifies just to 4. And if you're unsure, you can put that in your calculator, make it look like the double brackets in your calculator, and it will simply give you 4. Now we need to rationalize. We need to simplify fully. It doesn't actually tell you to rationalize. It says simplify fully. You need to know if there is a surd on the bottom or the denominator of a fraction, I need to get rid of it. That is something you need to know, not to be told. You should just know it, okay? How are we going to do this? We are going to get rid of this root 11 by simply timesing it by root 11. And remember, whatever you do to the bottom, you do to the top, times the top by root 11, which will give me 4 root 11 times the bottoms together gives me 11. Okay, and that's that question complete. We've simplified it fully, we've shown our workings. There is one more lesson on surds, which will be surds 3. It is going to look at more rationalizing the denominator when we have not just one surd on the bottom, when we've got more than just a single surd on the denominator. So that will be next week, probably Monday or Tuesday. But hopefully you followed along. Hopefully you learned something. Thank you for tuning in, and I'll see you in the next one.